Hello guys, welcome back to my channel. And We're gonna solve another problem today from Codeforces itself. This is problem C of educational Codeforces round 185. Um, I wanted to do this one before, but I got the time now, so let's just do this. So this problem says that you are given two integer arrays, q1, q2, and then all the way up to qn, and then the array which is from r1 to rn, as well as an integer k. So we've been given two arrays and an integer k. You can perform the following operation any number of times, possibly 0. We can choose two integers x and y such that one is less than y, is less than k, is less than x, sorry, and then this is lesser than equals to k. And then there exists an index I such that qi equals x by y, rounded down, and then there exists an index j such that rj equals to x mod y. um, then we can remove this qi from array q, and then we can remove this rj from the array r. If there are multiple occurrences of qi and in the array q, only one occurrence is removed. Same for rj in the array r, right? Calculate the maximum number of operations performed on the given arrays. Okay, the constants are pretty normal, and then k is up to 118. Okay, so we need to maximize these number of operations, right? Okay, now we'll we'll begin the explanation. So this problem basically says is what this says is we've been given two arrays. First is q, which have like elements like this all the way up to qn, and then this we have a second array, let's call it r, and then it has elements like r1, r2, and then all the way up to rn, right? Okay, so what we need to do is we need to pick two integers and x and y. So we need to pick x and y such that 1 is less than equals to y is less than equals to x, and then x is less than equals to k. So this is the condition that this says uh, must hold, and then there exists an index I such that qi equals to x by y. So first of all, some qi value should be equals to x by y rounded down, and second of all, there should be some index j from r where rj must be equals to x mod y. So basically we need to choose x and y in such a way that we have these two elements from array q, and let's say from array q and array r respectively, and then what they're saying is we can remove these occurrences from the array q and r respectively, right? So we need to pick such elements so that we have this one, this thing x by y rounded down, and then x mod y in the array q and r respectively, and we need to perform as many as operations as we possibly can. Okay, so first intuition that I want you guys to think in, the first direction that I would say would be that in the problem they says some qi should be equals to x by y. We need to choose some integer x y in such a way that this qi must be equals to x by y rounded down, and then this rj must be equals to x mod y. So I need you guys to think in the direction that what would be the minimum value of these x and y. What should be the minimum value of x and y such that these these conditions holds, basically that x mod y is rj and x by y is actually rounded down is actually qi. So we can think in this direction that if we have an element, let's say this is qi is basically 3. Let's just take an example, and this rj is equals to 5, let's say. So what I can see here is that if rj is actually 5, then this is the remainder, right? Rj is nothing but the remainder x modulo y. Then we can see that y must be strictly greater than this rj, right? y has to be greater, strictly greater than this rj, because if it would be if it I'm sorry, if it have been something like 5, then this 5 would have never came. Instead it would have been a 0, right? If it would have been a 5. Similarly for if we would have chosen a 4, then this would have been a 1, right? Similarly if we would have chosen a 3, let's say, so this would have been a 2, right? So in order to get 5 as a remainder, we need to choose a number which is strictly greater than rj, or in other words we could just take rj plus 1, and this would be the minimum element which would give rj as a remainder, right? Okay, now we also need qi or when I divide this x by y, or x by, when I divide this x by y, then I should get this thing. So wouldn't you agree that the element I choose must be like the y I choose must be like uh, 3 times smaller than x, right? Something like that, or close to something like that. So basically I want to think is, for now let's just call this y. So let's say we choose y equals to rj plus 1, because we need rj as a reminder, and the smallest number which will give the remainder of 5 would be 6, right? 6 would give the would yield a remainder of 5. And then I want you guys to think now, if we take this rj plus 1 and we multiply this by qi, and we add a rj to here, right? So this actually becomes our x. Now how do we think like this? Because rj plus 1 was our, let's say, y, the smallest number which will actually yield this remainder, and then we need if we had chosen this as a y, then x must be 3 times of that. So 6 into 3 would be 18, right? And then we need to add this remainder also to that, right? So we'll add that remainder to that in order to balance this up. So now if we take x by y, round it down, so this would be what? Y would be 6, and then x would be 5 into, no, 6 into 3 would be 18, and then this would be 23. So this is 23, and now x would be 23 by 6, rounded down. So this is 3, and x mod y is 5. So you see that this condition holds. So we need to think in the direction what is the smallest, again I'm repeating. So we need to think in the direction that this when we would get a remainder of 5, only if we have elements which are strictly greater than this rj, and the smallest number which is strictly greater than rj would be rj plus 1. And then if we would have chosen this as a y, then we need to balance this in order to make this a qi. So in order to get 3 as a qi, we need to multiply this by 3, or let's say qi, so that if I divide this x by y, I get this 3 as a quotient, right? And I add this remainder so that this condition also holds, this one. And since this I have chosen y as rj plus 1, so this rj will not cause any issues. I mean this will not be a multiple of, let's say, rj plus 1, because this is actually greater than rj is actually smaller than rj plus 1, right? So I hope you're getting what I'm saying. And so this is pretty much it for the problem. So we can construct we can construct the answer like this. If we have, let's say, we have a test case like this. I'll just take this one. So 5 4 2 2 1. So I'm sorry, so this would be 5 4 2 2 1, and this is 9 8 9 800. So this is 9 8 9 800. So this is q, the array q, and this is the array r. So what I could initially greedily think is that, yeah, there's one more part left to the problem. We'll come back to it later, but for now I want you guys to think in the direction that should we in order to make the maximum number of pairs, what do you think we should do right here? Should we just sort these arrays, or sort these arrays, and then just take the minimum qi and group it with the minimum ri? So if we sort these arrays, so we will have 1 2 2 4 5, right? And similarly we would have a r like 8 8 9 9 100. And basically what I initially thought of was that I could take I could take the smallest qi and then group it with the smallest ri, then take this smallest qi, group it with the smallest ri, similarly and so on. But this actually gave a wrong answer here. So um, we can actually do better, right? So let's recap what we have just covered up till now. So I'm saying is, if we want these conditions to hold, that is x by y rounded down must be equal to some qi, and then x mod y must be equal to some rj, then what I'm saying is I could choose y as rj plus 1, and then I could choose x as rj plus 1 into qi plus rj, right? So now I want to guys to think in the in the direction that, so if we take these smallest pairs, obviously you might think that we will get a bigger answer, or then we will get the maximized number of pairs. But here is a counter case. So let's say, or also this x must be smaller than smaller than equals to k, because x has to be smaller than equals to k. It is given here, right? This condition that x has to be greater than greater than equals to k, right? Oh sorry, smaller than equals to k. So to disprove this observation that we will always take the smallest pairs, let's see, if I pair this up, and then pair this up, then we can see that these are arranged in an ascending order way, right? So this is, let's say, q1 q2 q3 and then q4 q5. This is similarly r1 r2 r3. This is r4 and r5. And so what I'm saying is, if I could group a q1 with r1, q2 with r2, and then q3 with r3, so what I can also do is take this r3 and group this with q1. If let's just try to think in this direction, because this q3 is less than or greater than equals to this q1, right? In the worst case it would just be equals to this one, but this can also be greater than q1 since we have sorted this array, right? So if I can form a pair like this, so I can obviously form a pair like this, because q1 is actually smaller than equals to q3 anyways, right? So I can form a pair like this as well, right? Similarly, if we would have something like this element, or we would have or we could instead of choosing this, we could also choose this one, right? Because this is the same as 9. So it might happen that we can also choose this one up, this ri, because if you will see this expression, then ri contributes the most part to this. If you can reduce the ri somehow, or rj somehow, I'm sorry, if we can if we can take the largest rj, or take the largest r, and then group it with the smallest q, then we would have these small r elements, and then we can group this with large q elements. Like we are actually trying to contradict our observation what we made here, that instead of just choosing the smallest pairs from here, we can instead choose the biggest ri and group it with smallest qi. Similarly, I could take the biggest rj, or the second biggest rj, or whatever, and then I could take the smallest or second smallest or whatever qi, and then we can group this up, right? So this is the core idea for this problem. that we take the maximum possible rj for any particular qi and then group them together, and then check for the next one, right? Check for the so what I'll do is I'll not sort this r in ascending order, I'll actually sort this in descending order. So 1 2 2 4 5, this is our array q, and this is our array r, right? So I actually will sort this in descending order. And now we can just see if we can form a pair like this, then there is nothing better than that, because I've taken the greedily taken the maximum ri and grouped it with the minimum possible qi, or I have taken the maximum possible rj and grouped it with minimum possible qi. Now all the elements to the right of this in the r would be actually equals to lesser than this rj, right? So this is following something like this, right? So I can see that I have already greedily consumed the maximum possible rj, and then I'm off to some smaller number, and then I could pair this up with this qj or qi. I could take this rj, pair this with qi, something like that. And this is the proper way in which in which the number of pairs would be maximized, I guess. We cannot do better than this, because we are instead of just taking the you know taking the least possible pairs or the minimum possible values for qi and ri, I'm taking the biggest possible value of r and grouping it with the minimum possible value of q at each iteration. So for instance, I'm here, I'll just check if rj plus or r plus 1 into q, or let's just call it ri plus 1 into qi plus ri, if this is actually smaller than equals to k, then I have formed a valid pair, and then we can move on to this one. If we haven't, then I'll just reduce this r and we'll check with here with this rj. If it is a valid pair, then we'll move, otherwise we'll just shift this to this, right? So in the worst case, what would happen is we'll have these pairs which we initially had, I'm sorry. So we initially had these three pairs, and in the worst case we cannot form any of the pairs with the later elements, and so we'll have the same answer as this one, as taking the smaller elements, right? Because see, the thing was that the thing we can see here is, if we follow this idea that we are greedily picking in each iteration the smallest possible numbers of q and r respectively. So if we go in this iteration, then I'll see that I have already exhausted all the possible all the minimum possible values for q and r. And so if the answer is not possible here, so the answer will not be possible here as well. So this is a predicate function, so if it becomes false, it remains false, right? So if we need to pair this r, we cannot pair this r, right? But if we would have paired it with some, let's say, a smaller qi, then we had a chance to pair this one also, right? Let's say we could have such a case, or you guys can try to create such a case where if we pair this with the smallest possible qi, then we might have a chance to pair this r and pair this or take this r and pair this with this qi, and so the number of pairs instead of 3 now becomes actually 4. So we take this and pair this up with this, right? Something like that. So number of pair formed increased by 1 here, right? So this is the core idea of the problem. Instead of taking the minimum elements greedily, we take the maximum r and try to group it with minimum q, right? So I hope this must be clear to you. The main thing was figuring out what would be the x and what would be the y, but I think this is not very hard to figure out, because this is just a mathematical expression written here, which I think wouldn't be much too hard. to figure out. And I think this would be a simple two-pointer approach to implement this. I'll show you guys the code just in case. So this is the code for the problem. I'm taking the array q and r as input, then I'm sorting both the arrays, I'm reversing the r, so I have this in descending order. And so I'm checking this condition that if my r plus 1 into q plus r actually becomes greater than k, so I'll reduce the r in that case. Because this is sorted in descending order, this is actually reducing the r, and I'll just continue in the loop. Or if I formed the valid pair, then I'll just increase my answer by 1, and then I'll increase both I and j, so I could search for next elements, and then I'll just print answer. So this is it for the problem. I hope you guys got it. But if there are any doubts, I think my explanation for this problem was a little bad, but I gave my best, I guess. But in any case, if you guys have any doubt, just let me know. I'm more than happy to help. Thank you so much for watching.